Find the power series representation for the following function. Also find the interval of convergence. So we have function tangent inverse 2x over x squared. And as we know, the power series for 1 over 1 minus x is given by n from 0 through infinity of xn. So x, anything here, that raised to n. Okay, and this is valid whenever absolute value of this is less than 1. So somehow we need to convert this in the form of 1 over 1 minus something. Okay, and this is, in fact, we can rewrite this function as 1 over x squared times tangent inverse of 2x. So if we are able to find the power series for tangent inverse 2x, then later we multiply by 1 over x squared and get the power series for fx. So let's try to find the power series for tangent inverse 2x. So somehow we need to write this in the form of 1 over 1 minus something. Okay, and we know the derivative of tangent inverse. Let's do that. We know the derivative of, so I'm trying to find if we can write this tangent inverse of 2x by differentiating or integrating in the form of 1 over 1 minus something. Okay, let's find the derivative, because the derivative is much easier than finding the integral. Okay, so tangent inverse of something is, from chain rule, 1 over 1 plus this square, 2x squared, that's 4x squared, times, from chain rule, derivative of 2x, which is 2. Okay, that is in fact 2 over 1 plus 4x squared. At least this is in the fraction, like 1 over, and we can always change this fraction in the form of 1 over 1 minus x. So this means if we integrate both sides, this implies entire derivative of this 2 over 1 plus 4x squared with respect to x is tangent inverse of 2x, and plus c, but that's a minor thing. So to find the power series for tangent inverse of 2x, what we have to do here is find the power series for 2 over 1 plus 4x squared. Find the power series for this and integrate. As we know, we can integrate or differentiate power series term by term. So once we have the power series, we integrate and we get the power series for tangent inverse 2x, and plus c, and we'll find c later. So we need to work with this fraction. Okay, so here we start with 2 over 1 plus 4x squared, and we want to rewrite this in the form of 1 over 1 minus something. So 2, we can factor that out. So 1 over 1 plus 4x squared is 1 minus negative 4x squared, just to match 1 over 1 minus something. Now we have power series for this using this formula. So 2 times sum n from 0 through infinity, look at here, that thing x, common ratio, raised to n. So in our case, negative 4x squared raised to n. And this sum is valid as long as absolute value of x is less than 1. That's absolute value of negative 4x squared is less than 1. Okay, let's simplify this. To outside n from 0 through infinity, this is negative 1 times 4, so negative 1 raised to n, 4 raised to n, and x raised to 2n. Okay, and let's simplify. This is negative 1, and absolute value of negative 1 is 1, so negative is gone. This 4 we can pull to the right hand side, 1 over 4. So this is same as x squared less than 1 over 4, and we don't need absolute value because x squared is always positive. Now we can take this 2 inside and combine with 4n, because 4n is same as, in fact this can be written as 4 is 2 squared and n, so 2 raised to 2n. And when we take this 2 inside, we just add the exponents, 2 raised to 1, and we are multiplying 2, 2, 2, 1 plus 2n, or 2n plus 1. Okay, so this is sum n from 0 through infinity of -1 to the n, for n is 2 raised to 2n and is 1 plus 1 times x raised to 2n. That's the power series for 2 over 1 plus 4x squared, and this is valid when, let's take square root both sides, then absolute x less than 1/2. Okay, so we look at the right hand side, come back here. So we have the power series for 2 over 1 plus 4x squared, which is here. Now we're going to integrate both sides. So this is, let me write over here, this is 2 over 1 plus 4x squared. Now integrate both sides with respect to x. With respect to x, then this antiderivative gives us the right function we are looking for, tangent inverse 2x. Okay, our goal was to find the power series of tangent inverse 2x first, then divide by x squared to find the power series for the given function. Okay, let's integrate here. Then we get this one, that we get tangent inverse of 2x plus some constant is equal to, we can do term by term integration. So this integration is in fact applies to x raised to 2n. This is now n from 0 through infinity of -1 to the n constant, and we got 2 raised to 2n plus 1, another constant. Now we integrate x raised to 2n from power rule, that's the x 2n plus 1 divided by same thing, and this is still valid, absolute x less than 1/2, which is same as -1/2 to 1/2. Okay, we are done, almost done, but we need to figure out the value of c, and this power series is valid as long as the x is in between -1/2 and half. To find c, let's take x equals 0, then we have tangent inverse 0, which is 0 plus c equals, x is 0, so 0 raised to number is 0, so everything is 0, so that means c is 0, so c has no effect. Okay, then we have the power series for tangent inverse of 2x, which is here, 2 raised to 2n plus 1 x raised to 2n plus 1 over 2n plus 1, and this is valid on -1/2 to 1/2. Okay, but if you go back all the way up, we are supposed to find the power series for tangent inverse 2x times 1 over x squared. That's the function. So we found the power series for tangent inverse 2x. Now we divide by x squared or multiply by 1 over x squared. Thus our function, which is tangent inverse 2x over x squared, that means we divide this power series by x squared, or equivalently we multiply by 1 over x squared. So that works with this, n from 0 through infinity, -1 to the n, 2 raised to 2n plus 1, and I can write this 2n plus 1 anywhere, that's on the bottom, so I'm going to write 2n plus 1 here. Now we are dividing by x squared or multiplying by 1 over x squared. So when I divide or multiply by 1 over x squared, then we have same base, x, 2n plus 1, and this 2 goes to the top, minus 2, so it becomes 2n 1 minus 2 -1. Okay, so for the given function, which is tangent inverse 2x over quantity square x squared, is given by this power series, and this is valid on this interval -1/2 to 1/2. Okay, final.